Today's lesson is on 8.1 as well as 8.2. So 8.1 is what are fossil fuels, and then 8.2 is extracting coal and oil. What are fossil fuels? So coal, oil, and natural gas are the commonly used fossil fuels. So instead of being converted into fossils, which we see like bones and things of dead organisms, that organic material becomes piled up on the bottom of a swamp or a lake or ocean, and then it gets covered with many, many layers of sediment. The layers of sediment are often several kilometers thick, and then heat and pressure changes that decaying organic matter into coal, oil, and natural gas. And those are the three materials that are the fossil fuels. All right, so here is just a diagram showing what is happening to basically make fossil fuels. So they do take a long time to develop, and this diagram here is showing how different types of coal developed, and crude oil also developed in a similar way. So the remains of ancient swamp vegetation that lived about 300 million years ago is how coal was formed. Plants died and fell into the swamp, and then their organic material got covered by layers of sediment, and there was no oxygen in those layers, so the plant material couldn't decompose. Hydrogen and carbon from the organic material got locked together underground, and then eventually they formed a solid layer of lignite, which is a soft coal. All right, so then after that, more layers of sediment piled on top of the lignite and compressed it even further. The layers were so deep so that because the layers were so deep, there was a lot of pressure, and as well temperature increased. So the temperature increasing and the pressure increasing, it compressed the lignite into a harder coal called bituminous coal. In some layers of bituminous coal were compressed and heated even more, and this produced an even harder coal called anthracite. All right, so lignite was the soft coal, and then bituminous coal, and then the harder coal called anthracite. All right, next is the uses of coal, oil, and natural gas. So let's take a look at coal first. It's been used as a fuel for at least 3,000 years. It's abundant in most parts of the world, but was used only a little until the invention of the steam engine. So then for more than 100 years, steam engines were used to power factories and move people and goods. Why is coal used is because it's cheap, it's easy to mine, it's easy to transport. And that is why it provided almost all of the thermal energy for the steam engines that made our country grow, and why it's still popular today for some industrial uses. Oil and gas have not been used for as long as coal has been. The discovery of natural gas was probably when there were some ancient eternal fires burning in the Iraq area. Those were reported by travelers 1900 years ago, and it was probably the result of natural gas escaping from cracks in the ground and then being ignited by lightning. So natural gas, it is more difficult and dangerous to control and transport, so that's why its potential energy has only been used in recent years. Crude oil, which is also called petroleum, is found as a liquid, and it's extracted by drilling a hole into Earth's crust, and because the oil may be under pressure, it'll come out of the hole on its own, or If it's not under so much pressure, then it has to be pumped to the surface. All right, there's a couple of videos we'll watch here, and then these are the questions for 8.1. All right, so 8.2 looks at extracting coal and oil. And so since the late 1800s, the coal industry has been an important part of Alberta's history. It was the main source for the Canadian Pacific Railway and most of Alberta's industries. Most of Alberta's electric energy is also produced in coal-burning thermal plants. Most of the iron and steel that's used in Alberta's industries has been produced in other parts of the world where those areas are using coal from Alberta to produce iron and steel. How is coal mined? So, like those videos showed, the coal that gets formed is developed into flat layers. And then depending on the area, they occur as thick beds or long seams. So over millions of years, these beds and seams of rock, they got folded and deformed. And then miners have to look for that seam or that bed of coal. There's sometimes deposits close to the surface of Earth that often get quarried in much the same way as sand and gravel would get quarried. And then deposits that are deeper below Earth's surface are dug using underground rooms and tunnels. Machinery can cut into the coal, and then conveyor belts can lift it up to the surface. Coal quarries are called open pit mines. All right, so here's an example of an open pit mine. Notice here how it does devastate the landscape. Trees and soil are removed to retrieve coal, and companies that are environmentally conscious will now reclaim the land. They'll cover it with topsoil. And they'll also grade the area to form a contoured landscape, and then they'll seed the area with native plants like grasses and trees. Okay, and this was an open pit mine in Germany being reclaimed. So oil. So 100 years ago, crude oil or petroleum was used to make kerosene. It's a fuel for lamps and stoves. Today, crude oil is the world's most important source of energy. In Alberta, the drilling for crude oil dates back to about 1914 when a miner named W.S. Heron noticed oil seeping from the ground on a farm near Turner Valley in Alberta. And so he purchased the land, the mining rights, and he started drilling. So this discovery of oil near Turner Valley, then later at Leduc, Woodbend, and Redwater made Alberta into a major oil producing area. And today, the province of Alberta exports energy to the rest of Canada as well as the United States. A problem with mining crude oil is knowing where to drill. All right, so searching for oil here. Notice on the legend on the left-hand side, the reddish is natural gas, black is oil, and the blue represents the water. All right, so basically here, as oil developed, it mixed with water and sand. That mixture, along with bubbles of natural gas, they seeped through porous layers of rock, and eventually it reached a layer of rock that it couldn't pass through and got trapped. The water, oil, and natural gas then gathered under that non-porous layer of rock. Because natural gas is less dense than oil, it's going to rise to the top. So this well D is showing that it is pumping natural gas, okay, because we can see it's at the red. A is going to get water. B and C, we can see, is going to get the oil. You can see the black layers there. All right, so diagrams like the previous slide, they give the impression that oil forms in large underground lakes. That's not always correct. Oil is found in microscopic pores between the particles that make up rocks. And then over time, changes in the Earth's crust cause great amounts of pressure. And that forced the tiny oil droplets into porous rock called a reservoir rock. And then further movements of Earth's crust help to trap oil and natural gas in sections of that reservoir rock that are located between layers of that impermeable rock. Seismic survey. There's a method called seismic survey. It's a technology to determine the location of potential oil and natural gas reservoirs. So shock waves from compressed air guns or thumper trucks or explosives are sent through the layers of the Earth's crust. Then the returning sound waves reflect off rock. They are detected by equipment and then used to create images of the underground rock layers. Then geologists can interpret these images and other data looking for structures that may contain oil and natural gas. All right, and then once seismic surveys identify likely places to find oil and gas, then oil companies will start to drill. When they hit the reservoir rock with oil or gas, the fuel may come to the surface on its own because of the pressure. But as the pressure drops, or if there's not enough pressure, then a pump is installed to bring the oil to the surface. So there's usually a pump jack or a lift pump used. And then the oil has to be refined. Once the crude oil is extracted from the ground, it will get refined into many different products. And it's done by a process called distillation. Like so, it allows people to separate the materials with a low boiling point from those with a higher boiling point. And then when oil is refined, it goes into a distillation system. Heavy lubricants like motor oil and kerosene will get separated from lighter liquids like gasoline and naphtha. Okay, and then we can see all the different products from the crude oil. Fuel oil, there's diesel, kerosene, gasoline, gas. Here at the bottom we have lubricating oil, paraffin, wax, as well as asphalt. All right, and then natural gas, which is found underground in rock formations. Like the video had showed a few decades ago, when people found natural gas, it was just burned off and wasted because natural gas was difficult to control. Oil was easier to control and transport. But today there are pipelines across Canada that transport natural gas. Trucks and ships have also been developed that can transport natural gas safely. And the use of natural gas it's used to heat houses and run industries. There's natural gas pipelines which run to towns and cities, thousands of miles from the wells, which deliver natural gas directly to consumers, including homes, schools, and factories. And natural gas is popular now because like the video said, it causes less pollution than either coal or gasoline. It also provides an immediate heat, which makes it excellent for cooking, because natural gas, when it's burned, that stored energy is transformed to thermal energy for heating and cooking. Energy in natural gas can also be used to generate electric energy, and then it'll also provide thermal energy needed in factories. Recently, vehicles have been developed that can run on natural gas instead of gasoline. All right, so lastly are the questions for 8.2 on page 143, numbers 1 to 6.